All right. So this is where we left. This is where we basically left. We wanted to determine the magnitude of angle C1, right? We wanted to determine the magnitude of the angle C1, and then we got it to be 70 degrees using some of the basics of trigonometry. So that means we move to 8.2.1b, whereby they want us to determine the magnitude of angle A2. Okay, so now remember, we have determined that angle C1, it's 70 degrees, right? That means the whole big angle will also be equals to 70 degrees. Do not forget that. So they want us to determine the magnitude of angle A2. Now, this is where angle A2 is situated, or perhaps to say located. This is where angle A2 is located, right? So now in this case, in order for us to determine A2, what are we going to use? You're asking yourself that, right? Ahmad, you have this angle, you have this angle, you also have this angle. Okay, I also have this angle, but this angle that I have just determined, if maybe I want to use combination of them, they're not going to help me to get that. But now I see, for the fact that I got this angle, I can get A2 because I am also provided with 35 degrees. That means when I have a look at a triangle A, D, C, man, angle C1, it is the opposite exterior angle of this triangle. This is literally exterior angle. That means I have only this one which is not provided, which is what I'm looking for. I have these two provided. Man, it's simple. So that means uh, angle A2, which is what I'm looking for, plus 35 degrees is equals to this angle, which is equals to C1. In this case, it corresponds with 70 degrees. Then what is my reason for me doing this? We're talking about opposite exterior angle of triangle. Now that means angle A2 in this case is going to be equals to how much? I'm going to say 70 degrees minus 35 degrees is equals to 35 degrees. So that means angle A2 will also be equals to 35 degrees. Okay. That's how we determine angle A2. Fair enough for 2 marks. Okay. So that means this angle over here is equals to 35 degrees. And therefore, we move to the 8.2.1 C. C, it says to us, okay, we want to determine the magnitude of angle B2 in this case. Where is B2? You go back to your diagram. This is B2. But now, how are you going to determine this smaller angle, which is B2? Now, we know the magnitude of the bigger angle, which is ABC, that this is equals to 70 degrees. Now we want to determine this. Is it fair for me to say this plus this? Yes, it is fair, but the problem is I do not have the magnitude of B1. So that means my unknowns here are there. I have two unknowns. All right, that means how am I going to determine B2? Now, we just determined this angle. So how will this angle be able to help me maybe to determine B2? Man, I see. Angle A2, angle B2 are equal. Because check this butterfly over here and then check the circumferences. Check this butterfly over here. Are you looking at the butterfly that I'm looking at? Angles in the same segment. So that means A2 is equals to B2 because we are talking about the angles in the same segment. Look at your circle. Look at the butterfly. These are the wings of the butterfly. This is the first wing. This is the second wing. Same segment, okay? So that means in this case, for 2 marks, we're going to say angle B2 is equals to 35 degrees as well. But now what is the reason? Angles in same segment, they are equal, okay? Or angle in same segment is equal to that one. So that means, B2 is also equals to 35 degrees. Therefore, we're done with 8.2.1. That means we move to 8.2.2. Now, 8.2.2, it says to us, hence, prove that BE bisects A angle BC. A angle BC. They want us to prove that BE, which is this line, it bisects this angle. Okay. Now, this is what is happening. When we say it bisects, it cuts into two equal parts. When they say it intersects, it cuts, but not into two equal parts. So that means this line, which is BE, can bisect an angle or can bisect a side. In this case, BE, because we are not sure if this side is equal to this side. So we can't say BE bisect AC. We can say BE bisect, intersect AC. So I just want to make it clear that we can bisect a side, we can also bisect an angle. We can intersect a side, we can also intersect an angle. Line can do that. So that means here, for a fact that they say it bisects, meaning into two equal angles. So now that means angle B1 supposed to be equals to angle B2. We are told so. We are told we have to prove that basically. Now, this is what is happening. We know that angle B2 is equals to 35 degrees, which is proven in number C, 8.2.1. So let us determine the magnitude of angle B1 to see if whether B1 is equals to B2. So that means we're going to say angle B1 is equals to 70 degrees subtract 35 degrees. Why am I writing this? Because in order for me to get B1, remember this angle over here, it's 70 degrees. This angle over here, which is B2, is 35 degrees. So that means B1 plus B2 is going to be equals to 70 degrees. If I want to determine B1, I'm going to say the huge angle subtract this angle. Therefore, I get B1. So that means B1 will also be equals to 35 degrees because 70 subtract 35 is 35. Now we can simply conclude that angle B1 is equals to angle B2. Both of them, they are equals to 35 degrees. Therefore, BE bisects A angle BC, since well B1 is equals to B2. That's when we can say the side, this length, this line, it bisects this angle into two equal angles. Okay, that's how we solve 8.2.2. Any question regarding this? No question. That means I move on. Now, 8.3, it says to us, AB is a diameter. That's very important. AB is diameter of circle center O, passing through points D, F, points D and F. CO is perpendicular to AB. CO, where is CO? Where CO is perpendicular to AB. It's not even indicated. Let's indicate it by ourselves so that we can always remember that this is a very important information. And therefore, ADC and the BFC are straight lines. These lines they are talking about. Okay, right. The only important information is that this is diameter, number one. Number two, this is perpendicular. We can see these are straight lines, so it's fine. So now prove. Yeah, it's straight lines because they're emphasizing on the fact that these are not tangents. These are not tangents. Literally, these are not tangents. So that's why they're emphasizing these are straight lines. So now prove stating reasons that CDOP is a cyclic quadrilateral for only 4 marks. Now, let's have a look at what they are talking about. CDOB. C, D, O, center, and the B. This thing over here, they say to you, prove it is a cyclic quadrilateral. Before we get to this question, this is what I want us to do. When they say to you, prove that a diagram, it is a cyclic quadrilateral, these are the basic things that you need to know, okay? Number one, this is the first situation that you need to know as a basic. So now, if you have a shape like this, and then you have an exterior angle. We'll talk about that. This is number one. Number two, if you have a four-sided figure like this, we'll talk about this. Number three, if you have a figure that looks like this, I'm sorry about that. I can't draw quite straight lines. Oh my God, let me try it. Let me start this afresh. This one is fine, even if it's not straight, it's fine. Where is pen? Okay, so let's say we have this, that, this, that, and that, right? So now let's start with this one. So these are the simple basics that you need to know. Each and every time when they say prove that is a cyclic quadrilateral, look for these three things so that you can know how to prove that. Now let's start with this one. So this one, if maybe let's say this is A, this is B, this is C, this is D. So here we have C1 and then here we have C2. In this case, to prove that A, B, C, D, it is a cyclic quadrilateral. This is how we're supposed to prove it. Angle C1 supposed to be equals to angle B1. So that means this angle supposed to be equals to that angle. Opposite exterior angle of a cyclic quadrilateral. This is the reason, okay? Opposite exterior angle of cyclic quad. Okay, so this is the reason. Okay, this is the first situation or the first condition. So when you are given a figure like this, go check, am I having these angles? Am I having angle which is exterior equals to this angle which is in opposite but interior? You're gonna look for that. Okay, I have D1, and then the opposite angle to D1 is going to be this angle over here. But I do not know the magnitude of this angle. I do not know the magnitude of that angle. Only if I know this is 40, for example, this is 40, then I can say this is a cyclic quadrilateral. Okay, that's the first condition. The second condition that you're supposed to know is that, let's say this is A, this is B, this is C, and this is D. In this situation, when angle A and then you add it to angle D, you get 180 degrees. Sum of opposite interior angles of a cyclic quadrilateral, they add up to 180 degrees. Even if you want to use C and B, you are still welcome. So in this case, if this is the case, then we can simply and safe to say that ABC, it is a cyclic quadrilateral only if this is true. If you know the magnitude of A and D and we add them, we get 180. So we go to your diagram and check whether this condition applicable. Now, this is what is happening. Do we even have the magnitude of the whole angle? Remember, this is what they want you to prove. It is a cyclic quadrilateral. Do I have the magnitude of D? Yeah, no, I do not have the magnitude of D, this angle, D1 and D2, D3, this angle. Do I have the magnitude of this angle? No, it can't be 90 degrees if that's what you are thinking. 90 degrees is only D3. And then D3, it is not on cyclic quad, but we'll talk of why it is 90 degrees. Do I have the magnitude of this one? No, I do not have. So if maybe I knew the magnitude of this angle and this angle, I was going to add them together. If they gave me 180, then I was going to say this is cyclic quad. And then C and D and O, no, they are not given. So that means we pass that one. And therefore another, which is a lot of people do not understand, is this one. So this is A, this is B, this is C, and this is D. It's okay. You don't have to have line here to show it's a four-figured shape. It's fine. This is cyclic quadrilateral as well. So that means if this is equals to that, we are safe to say this is a cyclic quadrilateral, okay? If angle A is equals to angle B, which is angles in same segment, we are safe to say A, B, C, D, it is a cyclic quadrilateral. Once more again, if this angle is equals to that angle, we can also say this. It is angle in the same segment, therefore A, B, C, D, it is a cyclic quadrilateral, okay? Now let's go to our diagram and check that. So now, this is what is applicable here. I'll show you how. But first, first of all, we're going to have to talk about this angle that it is 90 degrees, because remember, we are told that you can even see, we are told that AB is a diameter, AB is a diameter, and therefore we know that diameter subtend 90 degrees of this triangle. So that means D1 and D2 makes 90 degrees. And therefore that means D3 will also be 90 degrees, which is sum of angles on straight line. That means D will also be 90 degrees. Therefore, now this is what is happening. Now, this is what is basically happening. Angle O3, I agree, we were told that CO is perpendicular to AB, and we say this is 90 degrees. That means angle O3 is also 90 degrees. Now, when you have a look at this diagram, check your butterflies, okay? Check your butterflies. This is another butterfly. Okay, let me highlight it so that you can see it. Let me use a highlighter, because I'm sure a lot of people are not going to be able to see that. So that means here, check this. I'm highlighting it, okay? This is our butterfly, okay? This is our butterfly, okay? So D3 is equals to 90 degrees. O3 is equals to 90 degrees. That means DCBO, it is a cyclic quadrilateral based on this situation right here. Okay, so that means we're gonna say, this was tricky, guys. I don't wanna lie. If maybe you're able to see this, wow, you have to be careful. So that means to answer 8.3.1, we're gonna say, oh, we're done with it. Oh no, we're starting with it. So we're gonna say, this is 90 degrees given. So we're gonna say B angle DA is equals to 90 degrees. Why? Angle, I love using this reason. Angle in semicircle or subtended by diameter is fine, but I love using this one. So that means B angle DA, it's equals to 90 degrees. Why? Because it's angle in semicircle. That's the first thing. And therefore, I'm going to say angle D3 is also equals to 90 degrees. Why? Sum of angles on straight line. This is the reason, or you can say supplementary angles on straight line, supplementary angles. So D3 is equals to 90 degrees, because I'm going to say 180 minus this 90, still I'm going to get 90 degrees. I'm fine. And therefore, I move to this straight line, which is AD, my diameter. And I'm going to say angle O3 is equals to 90 degrees. You don't even have to give a reason, but you can give your reason and say CO is perpendicular to AB, which was provided that CO here on the statement, CO is perpendicular to AB. That means O3 is going to be 90 degrees. Therefore, you are safe to say angle D3 is equals to angle O3, whereby both of them, they are equals to 90 degrees. Therefore, you can say C, D, O, B is a cyclic quadrilateral. What is the reason? We used angles in same segment. That's why we say CD OB, it is a cyclic quadrilateral. Okay, that's how we're gonna do that question, right? Now, Are we still, are we coming, guys? Are we on the same page?
Yes,
Sorry?
yes, we are.
Okay, all right. As long as you understand, that's what matters. And therefore, now we move to 8.3.2, where it says, proof stating reasons that if angle B1 is equals to X, okay, if angle B1 is equals to X, let me do this. Uh, hey, what's happening now? Okay, right. So now, hey, so now they say to us, if B1 is equals to X, where is B1? Here is B1. Remember, we have proved this is exactly quad, okay? Just that I just wanna, this is X. Then D2 is equals to C1. Where is D2? They say D2 is equals to C1, is equals to C1. You are told that D2 is equals to C1. And therefore, oh, we have to prove that D2 is equals to C1, okay? We have to prove that D2 is equals to C1. We have to prove this. So they are not equal. We have to prove that. Okay, right. Fair enough. So now this is what we're going to do, okay? So we want to talk about C1, okay? And then we also want to talk about D2. Do not forget that we have proved that this, it is a cyclic quadrilateral, okay? We have proved that DOBC, it is a cyclic quadrilateral. Now, what I see about C1 is that C1 will be equals to B1 right away, because look at my butterfly. These are angles in the same segment of this quadrilateral that we have just proved. First thing is angle C1 is equals to X, which is B1. My reason is angles in same segment. That's why I'm saying C1 is equals to X. Now I moved to B2 because already I just found that C1 is equals to X. So that means I'm moving to D2. Now D2, where is D2 located? This is where D2 located. Now D2 also is equals to X, but you have to give a reason why. Why? D2 is equals to X because now look at this triangle, DOB. DOB. We have OD, we have OB. Now, this is equals to that because these are your radii, line from center to circumference, line from center to circumference. So that means if the opposite sides of this triangle are equal, that means the base angles are also equal. So that's why we say angle D2 will also be equals to X. But what is the reason behind that? You can simply just say OD is because OD is equals to OB, which is radii. Therefore, we can say now that angle D2 is equals to angle D1 because both of them, they're equals to X. That means they are equal as well. That's how we solve 8.3.2. Still do not have questions. Okay. Now, question number 9, it says to us, this is theorem, most definitely is proving theorem. I can see this is, what is this theorem? Theorem number 9 or so, Tancourt theorem. In the diagram below, PT is a tangent to the circle PQR at point P. Prove the theorem which states that QPT is equals to angle R. Basically, this angle is equals to that. We know that, but we have to prove that now. How are we going to prove that? Now, when proving this theorem, there are two different ways you can construct this theorem. So it's fine, I'll just construct either way. So that means we're gonna have to do what? We're gonna have to draw a line. I got my straight line. It's gonna disappoint, I know. Okay, let me try to be steady and slow. It's either you join PQ, still fine. Not PQ. It's either you join this line to Q or you join this line to R. It's up to you. It's up to you. So today I feel like joining what? Let me just join. Which one should I join, guys? Let me join R. It's fine. You see, it's up to you. So you have to know the two. So it's up to you which one you use. So let me join to R. Okay. Let me join to R. So now I'll most definitely say I produced. I have Baballo. I'll just say W to produce W Lisa. Right, it's fine. So that means to answer 9.1, let's start here. We start with what? Most definitely construction. This is given, everything is given, and this is required to prove, and then construction. We start with construction, most definitely. Construction. So we're gonna say, we're not even given a center, it's fine. And why we're not given a center here? We're supposed to be given a center. We're supposed to be given a center so that we can say this is 90 degrees over here. Yeah, so there is something wrong about this question. We're supposed to be given a center here. I'll just call this center O, okay? We're supposed to be given a center here. So now check, we start with a construction. Okay, so now because we can't say here it's 90 degrees, not knowing this is a diameter. So diameter is supposed to pass through center to circumference. So that's why. So that means we're gonna join what? We're gonna join PO to produce Y at circumference, respectively, with all due respect. Okay, this is not your cycle, respect it. So that means we're gonna join PO to produce Y at circumferences respectively. Now, now check. After doing so, we're gonna come to proof. We are going to prove now. We're going to prove. So now how are we going to prove this? It's up to you. We can start anyhow. It's fine. We can start anyhow, Shane. So now here, after me constructing, I can say I managed to produce. I can say I managed to produce angle. I'll call this angle R1. This R1, and I'll call this angle R2. And then here, after constructing, I'll call this angle P1. I'll call this one angle P2. Okay, after constructing. Now, proof here. So now in our proof, remember, our aim is to prove that this angle is equals to that angle. Basically, P2 is equals to R1. Okay. So now check. This is how we are most definitely going to do it. We're going to say angle R2 is equals to angle P1. Why? Look, angles in the same segment. Check your butterfly. This is my butterfly. Check your butterfly. This is my butterfly. So that means R2 will be equals to P1. Okay. Why? Because these are angles in same segment. Okay. And therefore, oh, now I know that these angles are now equal. Therefore, I'm going to determine angle P2, or you can determine angle R1, is up to you. So that means I'm going to determine, let me determine angle R1. Therefore, I'm going to say P angle RY. P angle RY is equals to 90 degrees, okay? P angle RY is equals to 90 degrees. Why am I saying this angle is equals to 90 degrees? Because it is angle in semicircle. Angle in semicircle, which is subtended by diameter that passes through center. And therefore, I'm going to determine angle R1 then. So I'm saying angle R1 plus angle R2, both of them is equals to 90 degrees because I have just mentioned that it's angle in same segment. That means R1 plus R2 is going to be equals to 90 degrees. And therefore, let me solve angle R1. So I'm going to say angle R1 is equals to 90 degrees subtract angle R2. But remember, we said that angle R2 up here is equals to angle P1. That means angle R1 is equals to 90 degrees. Where I see R2, now I write P1 minus angle P1. So I managed to determine my angle R1 in terms of P1. Therefore, I'm going to determine angle P2. So I'm going to say Y angle PT, which is this angle over here, also is going to be 90 degrees. This angle P1 plus P2 is equals to 90 degrees. Therefore, what is my reason? Radius, it's axiom 7. I don't know if you know the axioms from the basics, okay? Let me just erase this. So YPT is equals to 90 degrees, radius perpendicular to tan, okay? So this is axiom 7, okay? Radius perpendicular to tan is axiom 7. And therefore, what is YPT? YPT is equals to angle P1 plus angle P2. Therefore, we're going to say this angle is equals to 90 degrees most definitely. Now, let's solve for P2. I'm just going to write it here. We're going to say angle P2 is equals to, I'm transposing P1 on the other side of the equation, is equals to 90 degrees minus angle P1. Therefore, I managed to get my angle P2. I also managed to get my angle R1. So both of them, they're equal because they're equals to 90 degrees minus P1. And therefore, now we're going to conclude. What is P2? Remember, P2, it's QPT. What is R2? R2 is angle R, not R2, R1. What is R1? R1 is angle R, simply angle R, which is the very same angle. So you can simply say, therefore, Q angle PT is equals to angle R. Since well, both of them, they are equals to 90 degrees minus angle P1. You can construct it in this way. Does it make sense?
Mm.
I'm sure you guys are tired. we study, we don't sleep, guys. If you sleep, oh, tell yourself that you study, you don't sleep, because I also don't sleep. So you can construct it in this way, Babalo, if you want to. Is everything fine,
Mm-hmm.
guys?
Yeah.
Yolisa,
Yes.
can you hear? Is everything fine? Okay.
Yes.
Oh, just wanted to confirm, guys, because I can't just do these things meanwhile people are sleepy or something. So, okay, maybe I'll give you this as homework. I'll send it now because it seems like people are tired. Plus, we have 3 minutes remaining. So I wanted to do this question, which is 9.2. And I also, let me see what's happening now. I also wanted to do this question, which is 9.4. And that was going to be the last one. But we'll do again these questions tomorrow, and I'll touch up with other topics. So guys, let's call it a day. I'll complete these questions tomorrow if wherever maybe you struggle, but there is nothing difficult about this, honestly. Please do these questions, and then I'll send the other questions that I will do again tomorrow. Okay?
Okay.
Because it seems like people are tired now. Okay, guys. Is everything going well so far?